Hello, this one is about chapter 10, hypothesis test. So in this question, it's about 20 years ago, 47% of parents of children in high school felt it was a serious problem that high school students were not being taught enough math and science. A recent survey found that 194 of 700 parents of children in high school felt it was a serious problem that high school students were not being taught enough math and science. The question here is, do parents feel differently today than they did 20 years ago? Using alpha equal to 0.05 level of significance. So to test the hypothesis, first we have to verify the requirement. So the requirement here is the sample must be a simple random sample. Well, and then n times p naught times 1 minus p sub 0 has to be greater than or equal to 10. That means there's enough sample size in order to be able to do this kind of hypothesis test. All right. So, well, we do not know this one. It didn't really explicitly say that the sample is random, but we can assume that it's a random sample in here. And we also can assume that 700 is less than 5% of the total number of the parents who have children in high school. All right, so we're gonna just go ahead and make a assumption that this did fit into what we have in here, and then p sub 0 here is 47% converted into decimal point. That is 0.47. So n here is 700. Okay, so we have a 700 times 0.47 times 1 minus 0.47. Let's see if this one is greater than or equal to 10. If not, we cannot use the statistic to do this one because the sample size won't be large enough. Okay, so that is a requirement. Let's go ahead and give it a quick check. So 700 times 0.47 times 1 minus 0.47, and that will give you 174, okay, 0.37. So all right, so if we run to 175, so that is definitely greater than or equal to 10. So that means we got enough sample size for this question. Okay. All right, so this one looks like a proportion hypothesis. So before we do this type of question, we have to write down the known and alternative hypothesis. That is pretty much the question, the requirement for every this type of question. The known hypothesis, that means there's no difference, right? Known is zero difference, they're always equal. So we're gonna have a known here is that 20 years ago and now it's the same. So we're gonna have a p sub 0 equal to 0.47. Okay, and this one, it didn't say. A recent survey found out this many felt it was a serious problem in high school were not taught being enough math and science. Do the parents feel differently today? All right, so it didn't really tell you the parents feel better or worse today than they did 20 years ago. It just asked, do parents feel differently today? So apparently this is a two-tailed test, okay? And the alternative hypothesis should be non-equal to, because it didn't trying to test the greater than or less than. Okay, so that is the two-tailed test in this one. Okay, and this is also the statement. All right, this is the statement in here. Does the parents feel differently today? Okay, so that is the statement we're trying to test in here. Okay, so in order to do this one, there's two ways to do. One way is you can use the formula. The p hat will be x over n. All right, so p hat here is x over n. N is 700. X will be 194. Okay, 194. All right, and then we already have a p sub 0 here is 0.47. We have n here is 700. So basically, we can plug this whole thing into the formula to do the calculation. That is one way to do. After you find a g sub 0, you will be able to go to using the table, since this one will be a two-tailed test. Okay, two-tailed test. So you can find a g value and then read a p value in here. This is half of the p value because it's two-tailed test. So that is half of the, each tail is half of the p value. But I'm going to use the calculator because calculator can automatically giving you the p value right away. Okay, so going to the calculator here, go to stat, going to test. All right, and we're using the one proportion test, one proportion z test. Okay, so that is this one right here. Input p sub 0 is 0.047. X here, we say x here is 194. All right, n here is 700. And this is two-tailed, so I'm gonna hit a two-tailed test, and then we're gonna hit calculate. All right, so that is this one right here. We're giving you the z value is negative 10.22. All right, so my z value here is negative 10.22. I also give the p value directly from here. And this one is a scientific notation is 1.5894. Okay, so p value here, p value here is 1.5894 times 10 to the negative 24. Okay, so this is e to the negative 24. That one is a scientific notation, is times 10 to the negative 24 power. All right, if I want to round to 3 decimal point, this negative 24, so that means I will need to move this decimal point to the left for 24 digits. Okay, and that will be really long, so 0, 0, 0. All right, so I will need to have a 24, 1, 5, 8, 9, 4. So this one from here to here need to move 24 digits to the left. All right, so if I just want to round to 3 or 4 decimal point, like a 3 decimal point, how much do I get? I will get a 0.000. Of course, if you telling you in the electronic homework telling you to keep 3 decimal point, you cannot just write down 0. You have to have a 0.000. Okay, so that is this one right here. And apparently this p value is less than alpha, right? This alpha giving you this question, alpha is 0.05. So when p value is less than alpha, we reject a null hypothesis. Okay, so what does reject a null hypothesis mean? Okay, if p-value is less than alpha, so reject the null hypothesis. That means we have enough evidence to support this claim or this statement. Sometimes some of the book call this is the claim or this is the statement. Okay, reject the null hypothesis. That means we have enough evidence to support this statement. That means parents feel differently now than 20 years ago. All right. So now we are giving you the conclusion on how to do this type of question.